Thanks for checking out our channel. Here's going to be a hopefully repair video on this particular unit. This is a Gallagher M1000. This is a 10 store joule, like 5-ish, give or take, output. I'm not sure what the output joule was on this unit. But anyways, they sold a bunch of these things. These were, they started making this model in 2005. That's when it was launched. I think 2017 was the last year of production for this unit. So, sold quite a few of them over the years. This was a hot selling unit, pretty stout unit. This unit's about 11 years old. The 2013 model was when it was built. So, all the parts as of summer of 2024 are still offered for it. I imagine in one of these years they'll stop offering parts for it because they'll want to get into a newer model. So we're gonna plug it in here, or we're gonna take it apart here. I didn't bother plugging it in. I just don't. Sometimes I worked on enough of these things. I just kind of open them up and take a peek at stuff. How I like to open this, I like to grab it up here in the corner, like right up here. Make sure there's no bugs, wasp down in there, or spiders. Sometimes spiders like to make their home here. Grab the front like this hand, put your thumb right here, and kind of squeeze like this, and grab the back corner right here. Usually just kind of grab and pull, and the board sometimes wants to lift up because there's stuff inside that's grabbing. Just hold the board with your finger, and so it doesn't move. Usually you can just kind of work it off there. And go over here and do the same thing. What's mostly holding you up most times is a capacitor. This is capacitor kind of sits. This is the capacitor right here, but right. Hold on. Let me. There's a piece of double-sided foam tape that sits up against the capacitor when it's sitting right there, and that is sticking to it, so it's hold up against there. And the transfer sometimes gets hung up inside this little groove area that it's being held in that. Okay, so I didn't plug it in, so I don't know what's wrong with it. So we're just going to do some quick checks. Well, it needs a new board. You can only tell that. The new boards look a lot different than these ones. The capacitor's pretty low. 25 reads 20. So let's go get a new board. I'll show you why we had to replace the board. Probably blew the fuse, but right there, that piece is blown. And sometimes you'll see there's another one. There's another piece right there that's blown. So in these older versions, over time, areas right here for whatever reason would blow, either from a power surge or just age or luck, maybe. Typically the fuse blows too. The fuse looks okay. We'll check the fuse real quick just to see, but if it's bad, I'm not putting a new fuse in it because it's not going to solve our issue. No, fuse is good. Alright, so let me go grab a new board. And a new board comes with a new capacitor, new transformer, because they made a big change to these things later in their production run, about 2014-15. I think it was when they made that changeover. They had this is second generation board. They had a earlier one, looked a little bit different than it. The board went all the way across up here. It wasn't recessed down like this one is, and this didn't come down. It just went all the way across even. Had a same capacitor, different colored transformer. They were green in the earlier ones. The boards were basically most of it looked the same over here, as well as the back, but they did make some changes to it. Seen the first version and the second version. So let me grab the third version because you can't get the second version boards anymore. It's been 9 years since they built this board. Built this version board. Alright, here's the new board kit. I've already opened it out of the carton that it goes in. There's a new transformer capacitor. It comes with some instructions, module update, and the new board. So we're not going to use the transformer, and this transformer doesn't go bad all that often, but it's only used in this model. It will fit other models but the way the winding is on the side here, the voltage is not the right voltage output. Usually, when I've installed this transformer, the original one, the 2A 7018 transformer, the volts I could get out of the units that we put it in was like 4,000 volts, so it would work, but it's 4,000 volts, and the winding is not set the same way. So I'm just going to put that board and transformer off to the side. Now, pull the transformer off, and we'll show you some differences between the two, old style board and the new one. And we'll look at the instruction manual, guide, whatever. Talks a bit about what you have to do. Alright, here's the new board. Looks similar. You see some differences. You can see they've moved a lot of the stuff that's, you can see right here, a lot of the stuff that's been moved over to the front side of the board. You see this one doesn't have near as many things over there, but they have these big diodes on there now. They have a spot for them, but they weren't being used. There's a lot of similarities. Let's look at the back side. So there's the back of it. So you see this has still got all the stuff on there, but look at the back. This one doesn't have any of that stuff on there. So moved a lot of it to the front side. Now on the instruction manual thing, whatever comes with the board, it says remove existing lightning rod, which is that little copper rod, like a spark gap deal that they put in their old ones. And remove that because, well, for two reasons. They've got it built into the new board on the output side, as well as if you keep that in there, see how this board kind of has this notch and comes down a little bit. So that lightning rod ran across from about here all the way across there. And with this, there's enough space that it couldn't arc over to the board. Well, this board is all the way across the edge there, and that lightning rod would be resting right up against there. You can see this trace is all the way across there, and would arc, mess the board up. So that's why you have to get rid of that. You don't need it anymore. So we're going to take this ribbon cable here. It plugs in right there. There's these two little female spade connectors here. There's also two little windows right there. And they plug onto these two tabs right there. Kind of use those holes there to kind of look at what you're doing. Kind of see. And you can flip it over to the front to make sure. And you squeeze it together. And then we do have to reuse the two tabs off of this old capacitor. And this capacitor is going to go in the trash because it's low to start with, and plus it's not. If it was reading good, we'd keep it and use it for something else, because this capacitor is a little bit bigger. Capacitor 30 microfarad, where that one's a 25. And the transformer is a different part number as well. The old one was a 2A 7018, but when they made this revamped version, it has to use this transformer here, which is a 2A 7008. It's a part number on it. And because if you use that transformer with this board, the way the winding is set up between the transformers, it only put out like 4,000 or 5,000 volts. This transformer with this combination of board puts out about 9,000 volts. So see, it only fits in one way. You can kind of see the stencil outline here. There's these little edge here, this edge here. They actually put that on the board, right there, right there. So let's make sure that all four of the spades are straight. I just usually get them started on the right, kind of fold it over to the left. And that's that. And then the capacitor, you just pick them after bottom two tabs, or top two tabs. Just pick two of them. Make sure it's the bottom ones. I mean, you can rotate it up like that, and that'll be the bottom. As long as you pick two bottom tabs, whichever way you're holding it, doesn't matter. It just has to be plugged in this way. Okay, now we need cord. I usually squeeze on those because sometimes they'll widen up a little bit when you pull them off the board. And then we'll plug this in here. Now, whatever the issue is with this board, was a pretty common failure as they aged, and can't get any schematics for them. And whenever they made this new version, well, that solved all those little issues, and we rarely see this board ever come in for repair. All right, let's see here. Plug it in to the outlet. We're 9.1 kV, and it's lighting up all the lights. Let's put our tester on here to see what kind of, just to kind of verify the voltage, make sure it's actually making it to the terminals, which it probably is. And we'll see how many output joules it's got. We'll do a peak voltage reading first. Alright, we're going to look at this number right there with no load. My meter showing 9.4. This is 9.2, close enough. We'll put a 500 ohm load on it. It's probably dropped down around, let's see, maybe 6.7. My gauge is right here is 7. And we're reading 4 joule output with 7,000 volts. Let's move over to a 200 ohm load. .7, 5.5 almost, 5.4 joules. We kind of plateaued there. See, I like this gauge. It kind of tells exactly what's going on. See, it had that little light up here because it's warning you, hey, voltage is below like 3,000 volts. I think what that is. And you see the lights tell you at a glance how are things going with my fence. Am I loaded down pretty hard? Am I doing pretty good? I really like this model. This is a very good unit. This thing's 11 years old. The board finally went bad in the thing. Alright, so I have knobs on here. I don't know if I pulled the knobs off this thing or not. I don't remember now. So, well, this unit's done. We'll put the screws to it. It snaps on the front. It's going to squeeze on there and click it on there. And then we've got to put, oh, I've dropped this. The screws are sitting somewhere over here. There's one. But anyways, well, thanks for checking out our video here. Hopefully you learned a little something about the thing. And they don't make this model anymore. It was discontinued. I had about 13-year production run. I think from like 2005 to early 2018, something like that. 12, 13-year run. So pretty reliable overall. Don't see them. Earlier ones seem to be more problematic than the later ones were. But you know, it's been almost 20 years since they launched this model. So, but alright, this one's good to go. We'll call the customer up, give them a quote. I mean, a brand new unit today, either drop down to the M800, which is about a $400 charger, or you jump up to the M1100. That's about a $550 charger, but it's quite a bit stronger. That's 11 stored joules, and this is 10 stored joules. But that M1100, with it being an adaptive output, it outputs about 7.5 output joules, but this peaked at about 5.5 joules. So I think the transformer on those is a little bit more efficient than this one is. But the transformers, these things, I rarely ever have them go bad. I mean, they've been using this style of transformer since the 80s, you know, on older models. So it's a 40-year-old design transformer, so pretty bulletproof design. Rarely do they go bad even from lightning. Usually the board gets hit first, and then the transformer survives the rest of it 99% of the time. Alright, well, thanks for checking out our video. Until next time, we'll see you guys later on.